Great, so it's about that time. So I think we're gonna get started. If you've just joined, that's fine. Welcome, we're so happy you're here, and there'll be other participants coming in. So definitely introduce yourself in the chat, let us know who you are. And as we begin today, you can take a look at some of the incredible panelists and their social media accounts here, so you can look at the amazing work that they're doing and keep in touch with them as well afterwards. And definitely happy you're here. So first, I'll introduce myself. I'm Henry Gordon Smith, founder and CEO of Agritecture, and we are all about sharing knowledge, sharing data, and guiding others to understand the CEA sector. So it's such a privilege today to have these incredible panelists to talk about LED lighting and vertical farming. So it's really about growing smarter with LEDs today, and we have brought together a number of industry and science-based experts to answer your questions. Some of them were submitted in advance, some of them we're going to get today. And this is really about sharing more knowledge about LEDs and the exciting sector of vertical farming. So first, some Zoom etiquette. Please introduce yourself on our group chat. It'd be great to hear who you are, what company you're from, where you're located. It's a great way to get to know all of you. And we're so happy you're here. So please just take a moment to put in the chat and tell us where you're from. Tell us what your intention is. Maybe you can think about it yourself, or you can put in the chat already what you're looking for. Are you really hoping to learn more about specific products, spectrum, all of these aspects we're going to be covering. So set your intention today and make sure that you get the information you want. And definitely use the questions feature. If you see the Q&A button there, you can put questions in there, and we'll prioritize those questions as we get to the Q&A period of the panel. So I'm going to actually be asking some questions to our panelists first. We're going to have a little bit of a presentation from BIOS about their innovative lights and their LEDs for vertical farming. And then we're going to get to some questions from all of you. So I think I'm ready to go, and let's start to proceed. So as I mentioned, we're from Agritecture, and Agritecture is a global advisory services company with a digital product as well. And we started as a blog. So we really like to share knowledge. And we still have a very popular blog in the sector, probably the most popular, consistently posting unique content and syndicated content across the topics of urban agriculture, greenhouses, vertical farming, and even policy related to local food production. So definitely take a look. If you haven't, you can subscribe to our newsletter or on social media, whatever way you want to get this knowledge, it's available to you through Agritecture. We actually developed a consulting firm based on a lot of the questions that our audience asked, and we've advised on 150 projects around the world. And as I mentioned briefly, we have a new software called Agritecture Designer, which lets you estimate the CapEx and OpEx of any greenhouse or vertical farm in the world. You heard that right. Online directly, you can input the information from your local location, and within minutes get estimates about the yields, CapEx, and OpEx of that facility. So this is one way we're trying to share more knowledge and get people better prepared for the realities of CEA. And this, again, is our impact. So we have quite a global outlook on the industry. And I'm happy to also answer any questions that may come. If you have questions from your panelists, please just use the Q&A function, and we're going to go through them. But now let's get started with the actual webinar, The Future of Vertical Farming, Growing Smarter with LEDs. We're so happy to have the support of BIOS in this webinar and the incredible panelists here today. So let me first introduce our panelists. We have Robert Soler, VP of Research at BIOS Lighting. How are you doing, Robert?
I'm doing great. I've never had anyone mispronounce my first name. So last name is always mispronounced, but never the first name. So
you know, I'm stumbling. I think it's earlier in the day where you are, Robert. You're in California,
yeah,
right? But I'm in Rome. So I get a little bit of a card for that. So, but Robert Soler. So there we go. And we're so happy you're here. We're looking forward to your presentation later and all the questions. We also have Tim Shelford from GLASE. Tim, how are you?
Very good, thanks. Very happy to be here.
And you're calling from New Jersey, you said, or where was that?
Yes, I'm in East Brunswick, New Jersey, quite close to the Rutgers campus. So,
excellent, excellent. You're representing GLASE, which is a very exciting organization leading a lot of knowledge in this sector. And we're going over to Ricardo Hernandez. Excuse me, Ricardo. How are you doing, Ricardo?
I'm doing good today. Thank you, Henry.
Are you in North Carolina today?
I am in Raleigh, North Carolina today. Yes.
Very nice, very nice. So we've got incredible speakers here, and we're going to be kicking off the webinar and asking some questions. So let me dive right into that. So first, let's sort of begin with you, Ricardo. Can you tell us a little bit more about your work, first of all? And then I sort of have a question about how do LED lights specifically affect plant growth?
Absolutely, Henry. So my work at the university, we do research in controlled environment, and a lot of it is lighting. We work in lighting on sole source lighting, which is relevant to this seminar. And we also work in the greenhouse as supplemental lighting. We also look at the impact of lighting with other environmental factors and how we can manage all of those to improve plant growth. And when I say improve plant growth, I should say maybe improve objective goal, right? Some growers may want to have more biomass, while some growers may want to have a more compact plant, while other growers may want to have more phytochemical content. Whatever that is, we look at that as the goal, and then we use light and other environment to try to achieve that goal the most efficiently and sustainable possible. Now, going back to your question about the impact of spectrum, I'm talking about spectrum in this case. Let's say the impact of LED lighting in plant growth. I typically divide that into two cohorts. The first one is the impact of light intensity, right? And those are low fluence and high fluence responses. And it's basically, we can match that to photosynthesis, right? And typically we use 400 to 700 nanometers. And with new research right now, we know that some far rays can be also included in the impact of light intensity. And that's typically related to biomass production, yield, and growth. More photons typically create more yield onto a saturation point where the additional increase of photons reaches the diminishing returns, and then it's not as efficient to continue to add light. And that response depends on plant species, cultivar, and other environmental factors. But to keep it very simple, if we're talking about young plants such as the transplants and lettuce, perhaps between 13 to 17 moles per meter square for every day is a good average to grow those plants. And talking about, for example, tomatoes, we know that you need around 35 moles per meter square per every day to maximize the production of some tomato cultivars. I'm generalizing at this point, since cannabis is a very it's a plant that now is very popular in the US. Cannabis can, from our research, can take a lot more light, right? So we have found that typically even 50 moles per meter square per day on a cannabis at a specific density, we can still not saturate that yield response. So it depends on the plant species and cultivar. Now let me jump to the other side, which is now spectrum. In spectrum, I call these the whispering lights, right? And the whispering lights is those spectrums that actually you don't need a lot of intensity to trigger a response. But it also is tightly correlated to the intensity, because sometimes those responses can be diminished if the light intensity is too high, right? So those spectral responses and the ratio between those colors now create plant architecture and phytochemical accumulation and the main two. Let me give you a brief example. In the LED world, you use a lot of blue and red LEDs and more far red and white LEDs right now. But if we stick to the blue and red example, if you have higher percentage of blue, close to 40% or anywhere from 20 to 40%, and the rest being red, you will create a very compact plant. And you have mostly on the red, you may create a more 90% red, 10% blue. Your plant will still grow adequate, but now you're going to have a less compact plant. And another example now of another whispering light is far red light, right? Far red light can have shade avoidance responses. And it's important to understand how to use that whispering light, the far red light, to actually create the response. If it's used while you have your growing spectrum, at the same time, you're going to need a lot more of that far red light to create any response. But if it's used as an end of day signal, then you need a lot less photons to create a similar shade avoidance response. So intensity and spectrum. And I'm going to stop right there and allow for everything to keep evolving in this panel.
Yeah, super helpful. Thank you for the introduction. It's very helpful to understand that this is really about precision, right? You're trying to balance the spectrum and the intensity to create what the plant needs to be what you want it to be, right? What the result you want. I want to talk a little bit about that result. You mentioned a phytochemical response. For those of us who are not scientists, what is a phytochemical response, and why does that matter to someone who's growing something commercial, for example?
Absolutely. So phytochemicals, it's put it in a more basic terms, is the production of molecules in the plant that sometimes can be used for a specific purpose. Some of it may be nutritional content, right? You may have a lettuce that is more purple to have more anthocyanin, right? You can have anthocyanin heavy lettuce, right? But also maybe also for plant from pest plant interactions, and perhaps make the plant more resilient, right? And in that way, you can create phytochemicals in the jasmonic pathway that actually be more repellent to insects, right? Now, there's a big push right now in the vertical farm industry to create more flavor, more aroma, more involved experience with the palate right now. And so we can create some, with the combination of the genetics, right? And then now the environment, which is the lighting and all the other components, we can create that perfect combination to actually elucidate these phytochemicals, right? For taste, for smell, for flavor, for nutrition in the plant. So that combination between the environment and light can allow us to reach that goal.
Thank you. That's really helpful to help us understand. And you know, we have to make careful decisions about what kind of lighting you're going to use to create those reactions and how that relates to the other systems. And we're going to get to that in a moment. But first, let's have a little bit of fun, right? Vertical farming, urban agriculture, it's all had a little bit of hype and a little bit of excitement in the sector, especially with these investments. But let's talk about LEDs. What are some of the most overhyped benefits or claims you've seen about LEDs? Anybody want to begin? Tim, how about you?
Sure. So yeah, my background is mostly greenhouses, but I've certainly at Rutgers we do a lot of testing of fixtures for agriculture. A lot of what we see a lot of manufacturers that are sort of hyping recipes, certain colors of or ratios of LEDs to promote specific growth. And I don't know that there's a whole lot of science behind some of those claims. Another thing, a lot of effort and machinery goes into being able to individually control each fixture, whether it's to, dim a certain fixture or dim certain LEDs within the fixture. In a agriculture setting, it's usually, on or off, and usually it's full on and then full off. So having the extra complexity of all that additional hardware, it adds to the expense and also there's more things to break down. So.
Okay, but on the plant recipe piece, like, is it overhyped because it's sort of the branding of it? Because we did talk about this idea of controlling sort of what the phytochemical response would be and balancing intensity and spectrum. There's a little bit of a recipe there, but is it maybe that it sounds too simple, right? It's like, just plug it in. It simplifies. Is that the concern?
I think that, and also, they market it to a greenhouse where, most of the light usually comes from the sun. Right. Certainly it's different in a sole source system, but. Got
it. Yeah, so that's the value there is a little bit less. What about you, Robert? What do you think? What are some of the hyped up things you hear?
I certainly agree with Tim, and I'm an engineer as well. And so one of the things that drives me crazy is when people ask about having tunable spectrum and having all these things, because anytime you add complexity, you add more things that could go wrong and things that could break. And so I totally think that from a research standpoint, we should be able to tune spectrum and start eliciting the responses that Ricardo mentioned. And then that may turn into a recipe that Tim mentioned, but then you got to simplify it so that it's not a bunch of knobs that you change every single day, because there is really no evidence of the dynamics over the course of the day having an issue, which I actually would like to talk about as research things, because I think that's really interesting. But really, I think that it comes down to trying to get as many photons for the least amount of energy is probably the easiest way to start. And for production, that's pretty much what you want. You want to have good uniformity. You don't want to have bright spots that are going to burn your plants or keep them shaded in certain areas. And then, have a research module that could help you figure out some other things. But ultimately, production, you just want to be tried and true and reliable, because everything else is very complicated. You don't want your lights to be complicated.
I think it's great advice, right? If you're planning a commercial facility, you're producing a consistent product, you probably don't need dynamic lighting. This is what they're referring to with a tunable, where you can sort of change things in that way. But if you're researching something, if you're trying to produce a more aromatic plant or a more, maybe more THC in your plant, you may want to have a research module, a sort of section of your farm that's enclosed. You can do that research, and you may want to spend a bit more money for that research lighting to build not only a light recipe, but really your recipe for how you're going to produce that product, consistent with your operation and understanding what it might look like when you move it into the commercial setting. What about Wi-Fi and Bluetooth connectivity? We hear a lot of companies talking about this. Is this something I need? Do I need to be hooked up to Wi-Fi with every light?
I'll let Tim go first because he was shaking his head most emphatically.
Yeah, again, I think keeping it simple is especially when you have potentially hundreds of lights, and really if you're just switching them on and off, I don't know that it's really being able to communicate with every light is really necessary. Again, if you're in a research setting and you want to tune things and change things dynamically, maybe that would be a case where you would want to have it, but it certainly adds a lot of expense and complexity that you most likely don't need.
And yeah. Ricardo, sorry, Robert, go ahead. What do you think about the Wi-Fi Bluetooth connectivity piece?
I'm going to just jump on what Tim said, so we could hear what Ricardo has to say.
Ricardo, I just want to know from the research perspective, right? Because you are doing a lot of those. You probably work with grow chambers. Tell us a bit more about, what's the value of that dynamic lighting for you? What does it look like in the real world?
I think it's good to phrase the question around the current state of the industry. I have no doubt that while we discover more impactful recipes, right? We're talking about 10% difference, then it makes no sense, because then you're going to lose your money trying to have an excessive capex on a light that can change the spectrum to gain 10% difference, right? But we're talking now about 20%, 30%, 50%. Then when we get to those recipes and we can show that's the impact, then the engineers are going to have to come with a solution to that impact. Now, the solution can be versatile. It doesn't have to be overbuilt, right? But it may be a two different lights that can be controlled differently on and off in intensity to allow the same goal. But the current state of the industry right now, I think we still focus on efficiency, right? It's important, but you need to understand, going back to the goal, production goal. What is that production goal? If that production goal is to create biomass, the industry is ready to do that right now, and they will focusing on increasing efficiency will make the use of vertical farms more affordable and produce products. So I agree with that. Now you have different goals. For example, if you're trying to produce a young plant, and this young plant needs a specific morphology to fit into an automatic transplanted that go into the field, or to fit a specific operation, right? Then you may need more colors of light to reach that specific plant architecture, right? So again, it's goal oriented. Most of the industry right now is about yield and biomass, but how the science evolves through time, I think engineers are very fast to catch up and develop new products for that new science.
Ricardo, can you just briefly explain morphology to the audience?
Absolutely. So a very good example is plant architecture, right? How do you want that plant to look? Do you want it to have very compact, very thick and compact leaves? And that these thick and compact leaves, you can pack it with anthocyanids so they can have higher max photosynthetic rate when they move into a different growing environment. Then you need a certain type of recipe of life for that. Or if you need a plant that you want to have with lettuce that may have a lot of leaf coverage, so when it moves to a new environment, or allows you for canopy closure much faster, so you're able to capture all the photons that are being deployed, right? So you can create a recipe that now accelerates that leaf. Now that leaf is going to be perhaps thinner, right? But it may be able to reach a canopy closure faster. So it's the plant shape architecture, and you can use light and other environments to manipulate that for the specific production goal.
Thank you so much. So let's talk about LEDs relative to other types of lighting like fluorescence and HPS, especially in the context of vertical farming. Let's help our audience understand why you would choose LEDs. Tim, do you have some thoughts on that?
Sure. So high pressure sodium is quite popular in the greenhouse industry, and it's been used for years. In vertical farm situations where usually the lights are mounted much closer to the crop, LEDs definitely have an advantage there because they don't have as much radiant heat. I mean, they still do produce heat, but it's usually off of the drivers and it's not radiating right onto the crop. Certainly in greenhouse production, sometimes you want that heat, but I think in a vertical farm, usually that's not the case. And so that's certainly a major benefit. Also, the ability to turn lights on and off on a higher frequency is also a benefit. High pressure sodium, they don't really tolerate being turned on and off. But if you were trying to match like energy prices and you were trying to turn lights on when the electricity was cheaper, certainly LEDs are much more capable of operating under those conditions. So,
Robert, what do you think?
I'll jump onto that. Me and Tim are the engineers in here, so we're usually going to jump on each other. I think one of the other things is, fluorescence can be dimmed. So I generally think if you're having a racking situation, I'm thinking of comparing it to fluorescence. They can be dimmed, but they're not very good at dimming. So LEDs, if you're trying to hit, as Ricardo had mentioned before, there's a linear region of growth and then there's the saturation region. You kind of want to get right before you hit that saturation region to maximize your benefit. And so to have the fine tunability of LED, that could really push the PPFD to exactly what you want it to be. And again, it has better uniformity, and they are generally directional, which means that they're pushing light in only one direction. So you're getting inherent efficiency gains just from that alone. So I think that there's a ton of benefits. It's just usually investment is probably the only detriment.
Yeah, they're definitely more expensive up front, but there's a lot of benefits, right, from that you talked about. I mean, I think it was really interesting to say that the light is just more targeted in general. You're wasting less light. But there's also this element of heat, right, Robert? That's part of the issue too. Can you tell us a little bit more about why LEDs basically reduce the heat in the vertical farm, and why, imagine a large vertical farm, why is it so important to reduce that heat?
Yeah, I mean, I think at the end of the day, it comes down to watts in is the BTUs out. We could talk about, fluorescence will radiate the heat. So it'll actually go directly on the plant. The LEDs, they conduct the heat away. So it goes up, generally on a vertical farm that's still to a plant direction. So ultimately, it's just watts in, and you can reduce your watts dramatically using LED. Probably I would say over a fluorescent, I don't know, maybe about 50% I would say is what you'd waste in energy, or reduce in energy. So that's half the heat in your total system, and that's a big deal, especially if you're in a space where you're requiring some HVAC to reduce heat. That's going to be a big deal for you.
And you, Robert, you also said PPFD, and I just want to make sure the audience sort of understands. Can you give us a simple explanation of PPFD? Because they're probably going to see it in a bunch of LED or on your website when they look up your lights. So,
Yep.
What does that mean?
Yeah, so Ricardo mentioned before the energy, the number of photons between 400 and 700 nanometer. That's kind of par, photosynthetically active radiation. So the PPFD is the photosynthetic photon flux density, which is how much is over a unit area. And so how much par per meter squared is what that comes down to.
Per second, yep.
Per second.
Excellent. Thank you. So I've got a couple more questions here, but if you're watching, we're so happy you joined, and you can ask questions too. Just use the Q&A feature and we'll be getting to those in a moment. We've got a couple of questions coming in, but we would love to get more from you. Let's talk about energy a little bit more. There's a lot of discussion on energy use of these farms. Lighting is a significant part of it, but also the climate control in vertical farms specifically to reduce that heat is also important. You're stacking so many plants, so many lights, so that is also an issue there. I would really love to hear from you as experts. What are some of the strategies you've seen that are interesting or unique, or just the best practices for reducing energy use, increasing efficiency, and accordingly sustainability in vertical farms? Anybody want to jump in?
I can start, and then I can double back. So you have very knowledgeable people here in the panel. But so going back to that energy on the lighting, I think the most important point here that LEDs are the best solution for commercial grow plants, either in the greenhouse or in the vertical farm, is the ability to produce photons with less watt input, right? So you're talking about a fluorescent. I had to buy the high efficiency fluorescent. I did my own measurements. I think I got it between 1.2 to 1.3 micromoles of light for every watt of power for every second, right? So with around 1.2 for the high. And then, you know, you have double-ended HPS that are close to 2.0 micromoles of light, right, per watt per second. And then you get to the LEDs right now. Some of them have been advertised to 3.2 micromoles. So if you compare the 3 to the 1.2 of the fluorescence, you have a 150% increase on the amount of photons you get per watt of power. And you compare that to a HPA, you have 40%, 50% more, right? So this was not the case a few years ago. I'm talking about 3-4 years ago. You know, the LEDs were hanging out with the HPS, right? And so it was a much harder sell for the grower to tell them switch to LEDs, pay a lot more per fixture to get, you know, a little bit more efficiency. But now, to me, you know, it's as long as the capex can be worked out in the return on investment, is an easy decision, right? You're getting more photons for less watts of power that you're using. All right. So I'm going to stop right there on that comment, and I can go back on the energy.
Thank you. Tim, what have you seen?
Sure. So one of the major energy usage in vertical farms is actually humidity removal. You know, the crop is transpiring a ton of water, and you know, you need to be able to remove that so you can avoid, you know, diseases, and also so that they can keep growing. And so that requires a lot of energy, and usually that's through refrigeration. And you actually get into the situation where you have to heat up the air to get it back to the temperature you need to be at. So that's actually a potentially good use of waste heat. If you can recover that off of your LEDs through like a water cooled system, you know, that would be a good way to you know, use some of that waste heat to you know, gain some energy that you can use to reheat your air after you've refrigerated it to remove the humidity. Another technique that we use to improve the efficiency of photosynthesis is to increase the CO2 concentration. As you increase the CO2 concentration, you can use less light to get the same amount of growth. And if you're in a closed environment, that's sort of a perfect place to use it. So if you're not having to vent to the outer atmosphere. So
yeah, those are really helpful as well. Robert, any that you've seen?
Some of the, I mean, I'm a lighting guy, so so some of the things that I've seen are kind of relative to not having like a square wave, but actually ramping up light, because you're ramping up your heat and giving your HVAC the ability to kind of ramp up with it and also ramp down with it. I think that there's some strategies on the ends of the day to try to get a couple boosts of efficiency.
Excellent answers, really, really helpful stuff there. So, you know, we're getting a lot of questions from the audience. We're going to get into those in a moment. But Robert, I think it'd be really great to hear a little bit from you, a little bit more about BIOS and about your lighting technologies. Are you willing to share a little bit more with us?
Yeah, absolutely. I have some slides prepared. All right, so naturally brilliant grow light solutions is what we make. I lead the development, so I'm pretty proud of this, but I'm only going to keep it down to one because we really only have one product that's ideal for vertical solutions. So next slide. Just about us, we inspire to educate, which we're doing here, innovate the world through a biology first approach to light. And we are a NASA spinoff. That finger means next slide. So we are a NASA spinoff. My roots came at the Space Life Science Lab at Kennedy Space Center. And we believe in the power of life, create solutions that harness this power and optimize it. And we are helping life adapt to modern life by blending that evolutionary biology with revolutionary lighting solutions to make the world brighter. And that's my marketing hat. So some product benefits of what we do. Greater than 50,000 hour life backed by a 5-year warranty. Everything that we do is minimal form factor, but industrial grade. So there are some lights that are out there that are also minimal form factor, but they're not going to hold up to the elements like what we do. Everything's easy to clean glass, flat glass. We developed this rapid rack mounting system that you see here. So that installation is super easy to do. It integrates with the racks perfectly. And we do everything so it's daisy chained. I think Tim mentioned before some heat of the system. Well, we do it so that the power supply is remoted away. So you have less heat. You can basically put the power supply somewhere else so it's not going directly into your grow system. It's all, it's all really kind of designed to make it simple. I kind of hit on this before. Gimmicks are for marketing hype. We just want the lights to work, be efficient, stand the test of time, be easy to install, easy to change out, move around. It just has to be simple and productive. That's really what everyone should want. We do also do consulting and light mapping and everything to help make sure that you're getting exactly the PPFD that I mentioned before and the uniformity that you're looking for. So we'll help you out with that too. We have people just on the other side of that wall that are willing and happy to do that for you. And so just some more things about this this particular product, IP66, which means you could have a water leak in your system and it will still run. Ricardo mentioned this before. So this one produces 2.9 micromoles per joule at 89 watts. Some people put up to 3.0 or up to 3. Even maybe 3.6, but those are just red lights. So this is a broad spectrum white light that you could see. You could see what the plants are doing. You could see if there's any infestations or anything wrong with your plants. And again, it's designed for universal mounting. So it's really designed to be easy, simple. Whatever your racking system is, however it mounts, it's going to work because we have T-slots. We have this rapid rack system, and it can basically go and do just about anything. I think that's all I wanted to talk about. Just make sure that you knew that there was a product that kind of hit all the goals.
Yeah, I feel like that's a great presentation there and really talks about a range of products and a product specifically for vertical farming that solves some of the issues we were talking about earlier. So that's fantastic. And when you're saying a lighting plan, that is basically where the lights go, how many of them, how they're going to hit the plants, and it's adapted to the specific product that the customer wants to grow. Is that right, Robert?
That's right. Yeah. So so distance away, distance spacing, so distance away from the canopy, distance from light to light, and that'll achieve the lighting goals that you need for your crop. And then that plus the photo period or how long the lights are on will arrive at what Ricardo was talking about, which is when he was talking about the 13 to 17 moles per meter squared. That's the daily light integral. So we could figure out how long you need the lights on to achieve those criteria that he was describing before.
Yeah, excellent. So we actually got a lot of questions on this webinar. So I'm really, really excited. So we're going to go straight into audience questions to see how many of these we can get through. This first one is from our anonymous attendee, and they're talking about the sort of distance between the light and the plant. And so I think we're going to have to pick a crop to sort of answer this question. Maybe we can pick basil, a popular kind of vertical farm product. What's the typical distance between maybe the top of the plant and the light itself?
Is this to me, or does anyone else want to jump in?
You're giving a live lighting consultation here, Robert.
Yeah. I've been given. Usually, we're looking at 12 to 18 inches. So you can get closer, but then getting airflow to get proper transpiration becomes the challenge. So if you got it closer, that would allow more target efficiency. But if you get further space away, you get that channel for air to be able to go through. And then your target efficiency may go down, but as long as there's lots of overlap from like rack to rack, that light that's kind of going off to the sides that's not hitting your plant directly will go to the next one. And you'll still get really good efficiency that way.
You might also want to look at the uniformity of the light at the crop too. As you get closer, you might not have as much room for things to diffuse out, and that might be a worry as well. You're not getting uniformity at the crop level.
What we've actually seen is so the bar to bar spacing on our LLI at 6 inches. When you get under 2/3 of that, so 4 inches distance, that's when the uniformity starts breaking down. But it's actually really good once you're at kind of a 1-to-1 ratio of bar bar distance to the LED to canopy distance, that anything that or greater, then you're good to go.
Great, really, really interesting stuff there. This is also an interesting question I haven't gotten before, and this one is about really cleaning, right? So these vertical farms or any CA facility really needs to be completely clean and protected. This person, Adam, is really asking about the reality of that cleaning. Sometimes that means spraying down the system. Sometimes it means heating up the farm interior to kill the pests. How are LED lights more resilient to this? Are there certain, is this something that they can handle essentially?
Yeah, so that's a great question because they're not all the same. So some people, I think there was a part where everyone was competing for micromoles per joule, the most efficacy. And so some people did that by not having a cover over the LEDs. So we didn't go down that route because we knew that it was a dirty environment. You're throwing stuff in there. So IP66 was important, and being able to clean it was really important because it is a dirty environment. People are spraying them down with all sorts of things. The other thing that we did, as we learned, GMP manufacturing requires everything to be cleanable. So even the backside's cleanable because that's important. It's important to you as a grower, so it's important to us.
I think from that perspective, some fixtures use active cooling where they'll have powered fans to help keep the the LED fixtures themselves cool. And I think certainly that would be very challenging in a wet environment. And I think the manufacturers that use passive cooling with heat exchangers are definitely the way to go in that situation. And also active cooling is another component that can fail as well.
Yeah.
So we got a question.
And it also uses more electricity. Oh, sorry, Henry.
Oh, go ahead, please. Yeah.
The active cooling also tends to reduce the efficacy too, because you're using more power to run the cooling fans. So that's also a little bit more power loss there.
So we got a question about dynamic lighting here as well, a little bit more. Like really, they want to understand, Paul wants to understand how much is the additional cost / complexity is added to an LED fixture by making the light intensity variable versus just on and off. Give us some order of magnitude to understand those differences.
So from an LED standpoint, it's free. Like the technology has come so far, it's no more expensive. All it requires is a controller to act. So it's a 0 to 10 volt controller to be able to do that. But you could get a 0 to 10 volt controller from Home Depot or Amazon, and it'll be sub $100. So, and that could control, I want to say, dozens of lights. We've had differences from control system. Some do like, maybe 20, some advertise they could do 1,000. But we could do tens of fixtures with $100 worth of controls. But from an LED standpoint, the technology has come so far that it's included. It's like HC on a car. I'm sorry, AC on a car. You just now get it.
Ricardo, I want to ask you a couple questions as well. This is about cost. I assume through your research you've had to select different lights, and the question here is: does it really make a difference which LEDs you use? Some are inexpensive, some are expensive. I think we're trying to make the point about it makes a difference, but let us know again, why is it important, and what have you seen in some of the cost differences as you shop for LEDs?
Well, yeah, I think the cost at the research point is a little bit irrelevant in terms of, we do stuff in a small space and we have the know-how to put things together. So sometimes we buy lights that have a lot of controlling for research purposes, and we do not intend to recommend those lights for commercial purposes, right? But instead we use those to come out with a commercial-based recipe that then can be adapted by the light, right? So typically, we are agnostics to the LED brands, and how long as we're trying to reach to that experimental goal. Yes. Yeah. Now we talk about commercial cost on how much it costs to operate. We then take that research and translate it to commercial scale, right? We take that and say it doesn't matter if I use 100 watts if it's not going to be the case. On a commercial level, right? So then we translate that to commercial level. And when we do that, depending on what we want to do and depending on the amount of light you want to deliver, then we can estimate how much it will cost per day, per meter squared, depending on the light intensity and the fixture efficiency for a commercial facility, for example.
But really, there could be serious consequences to just judging it based on cost alone. You need to take some serious time to plan and think about what's the plant you need. Are you trying to push aroma, quality, or are you just trying to produce yield? This is really what our panelists have emphasized over and over again. It's what do you want to achieve, and how does the light help you deliver that, whether it's research or production, or really focusing on a more nutritional, higher quality product. Isn't that right, Ricardo? That's what it's about, is that planning?
Yeah, and it goes back to the bottom line, right? So the grower has to make money, right? And you can make a system as advanced as an NASA spaceship, but the point is the bottom line, But what I can comment, for example, is that cost of electricity right now per meter square is becoming less and less, has the total cost, right? To give you an example, if you would have a facility with a LED efficiency of 2.9 or 3, and assume a electricity cost of 9 cents per kilowatt hour, you can power a meter square with 700 micromole intensity with around 42 cents per meter square per day, right? Or if you do 150 micromoles intensity, which is a lot less, you go down to around 15 cents per meter square in the lighting cost if you have that kind of efficiency and that kind of cost. Depending on the value of what you're producing, right, then those costs become sometimes very inexpensive, right? If you're producing cannabis rice and then you're getting a lot per pound, and you can get a lot more flower with high light intensity, then the cost of adding the light is fully justifiable, right? So depending on the value of your crop, you can consider the operational cost of this technology.
Can I just jump in with one thing?
Yeah.
So one of the things that, and this is answering this question, but also something that came up in the chat, which is about lifetime of LEDs. And everyone advertises. I think it came up in the hype session that people advertise that LEDs are going to last forever. And it really depends on how you drive them. They are solid state solutions. So one of the things that you could do is you could have less LEDs and you could drive them really hard and you could stress them out. Or you could underdrive them, and that will actually make them perform more efficiently, but they're going to last that long. So when we do our testing, no one should say, if they say 200,000 hours, I think you said 20,000, but I think you meant to say 200,000 because 20,000 is very easy.
20,000 is possible.
200,000. One, you're not supposed to ever say that, because you basically have a criteria of 6x the amount of time that you use to test. And the longest test is 10,000 hours. So you could only say really 60,000 hours. But when you look at the data that drives that, I mean, they're at 10,000 hours, they've degraded maybe like 1%, if even that. A lot of times they go up for the first, few thousand hours and then start kind of coming down. So, I mean, if you drive these things properly, they will last like forever. The power supply may not last forever, but man, those LEDs will last a really, really, really long time. So it does make a lot of sense to make sure you do the proper planning, get the right LED, and it does matter. The micromoles per joule could point you in the direction of what that lifetime is actually going to be. But from a design side, that's the difference between having something that's going to last you, 10, 15 years from now versus something that's going to burn out in 2 years.
Yeah, really excellent point there as well. Again, about those choices and focusing on the quality and the longevity of the product. I want to thank all of our panelists today. You were all phenomenal, gave a lot of insight, and we appreciate your time. And of course, thank you to BIOS for sponsoring this webinar and sharing education and knowledge on this topic of LEDs. Really appreciate that, Robert, and the whole team at BIOS. You can learn more about our panelists. Go check them out. Go learn about the research that Ricardo is doing. Go look at the organization at GLASE and what they're doing for the industry to connect and to share knowledge. And of course, check out BIOS and take a look at their lights. Some of the questions that came in were a little bit more about vertical farming in general. If you have questions about that, planning a business, reusing space, developing countries, please contact Agritecture. That's a lot of the answers that we provide as well. So take a look at our sponsor bios, and thank you so much for joining today and your engagement. Thank you, everyone.
Thank you.